Hey guys, today we are going to do Norton Theorem. First we are going to understand its basic concepts and definition, then we will do a couple of questions. Now you will see that Norton Theorem is very similar to Thevenin Theorem. If you haven't watched my video on Thevenin Theorem, I have provided the link in the description below. Please do watch that first so that you are able to understand this video better. So now we will understand the basic concept behind Norton Theorem. Now the Norton Theorem states that a linear two-terminal circuit can be replaced by an equivalent circuit consisting of a current source IN in parallel with a resistance Rn. Now the first line states that we have a linear two-terminal circuit with terminals A and B. First we have to find IN, which is the short circuit current through the terminals AB. That is, in order to find IN, we will leave the circuit as it is and short circuit the terminals A and B. From there we will find the value of IN which will flow in this branch. And secondly, when we have to find Rn, we will solve it exactly the way as we solved for RTH in Thevenin theorem. That is, if we only have independent sources, we will turn them off in this circuit. If we have independent sources, we will turn them off and find the value of Rn across the terminals A and B. But if we also have dependent sources along with independent sources, then we will keep the dependent sources as they are and turn off the independent sources and also assume 1 volt voltage across the terminals AB and then find Rn. It is exactly the same way as we found RTH in Thevenin theorem. Now we will take these two values and put this like this, that is, we will place Rn in parallel to the current. This is our Norton equivalent circuit. Now similarly, if the question asks that we have to find Vn or Vth, that is Vn or Vth, we can find that by using the formula I into R, that is In into Rn. And one important thing that you should also keep in your mind is that the Thevenin resistance, that is RTH, is always equal to the Norton resistance, that is Rn. Now we are going to do a couple of questions including both the cases, that is with dependent sources as well as with independent sources, and get a good hold on our concepts. Now in question number 1, we have to find the Norton equivalent circuit at the terminals A and B. Now we can see that in this question we do not have any dependent sources. We only have independent sources, that is a 2 ampere ammeter and a 12 volt voltage meter. Now firstly we are going to find RTH. For that we are going to draw its equivalent circuit, that is, we will open this part and short circuit the 12 volt. That is, we will have 4 ohm resistance will come here in series with 8 ohm resistance and 5 ohm resistance will come over here across the terminals A and B. Now here we will find the equivalent resistance, that is Rn by, that is 5. We will solve it parallelly with 8 plus 4 plus 8 as these three resistance are in series and they are in parallel with the 5 ohm resistance. So from there we will get 4 ohm, that is Rn will come out to be 4 ohm. Now similarly, when we will find ISC or IN, that is across this part AB, we will short circuit AB in order to find ISC and leave the circuit as it is. That is ISC, let us consider that it flows from A to B. So now we will draw an equivalent circuit in order to find ISC. So now we have drawn our equivalent circuit for ISC. So now we will consider some variable currents in each loop. That is, in the first loop we will consider I1 and the second loop we will consider I2. Now you will see that as this is the short circuit, now you will see that as we have short circuited A and B, no current will flow from the 5 ohm resistor. That is, it will be removed. So that is why we have considered I2 to flow in this whole loop. So we have only 2 loops over here. So from the first loop we can directly see that value of I1 is equal to 2 ampere. And from the second loop, on applying KVL, we will get 20 I2 minus 4 I1 minus 12 equal to 0. Now from these two equations, that is from this one and this equation, we will get the value of I2 as 1 ampere, which is equal to ISC or IN, that is over here. So we have found out the value of ISC and RTH, which we found out to be 4 ohm previously. Now we will draw the Norton equivalent circuit using ISC and RTH. So over here we will put ISC, which has come out to be 1 ampere, in parallel with RTH, or we can say this is RN, that is 4 ohm, with the terminals A and B. So this is our final Norton equivalent circuit. Now there is another way to solve this question without finding out IN first. That is, we can find the value of VTH that we used to do in Thevenin theorem, and from there we can use the formula ISC is equal to VTH upon RTH. That is, instead of finding ISC, we can first find VTH and put it in this formula and find the value of ISC. But as they have asked us to find out the Norton equivalent circuit, it is advised that you follow this method only. Now we are going to do a second question, which is much more difficult and trickier than this question, as in that question we will also have a dependent source involved along with the independent sources. So now in the second question, we can see that we have one dependent source and one independent source. So first of all, we are going to find Rn. Now in order to find Rn, we will remove the independent sources and keep the dependent sources intact. That is, the equivalent circuit for RTH or Rn will come out to be, that is 4 ohm will be here. We will leave the dependent sources as they are, that is 2Ix is in parallel to the 5 ohm resistor. Now the main part of the question is that now we will have to attach a 1 volt voltage source across the terminals A and B. Now we have done this because we have one dependent source over here. So we will assume this in order to find Rn or RTH, and we will also assume a current that is flowing over here, that is suppose I0. Now we can see that no current will flow through the 4 ohm resistor because we have short circuited the circuit over here. That is, we can see that Ix is flowing over here. So if no current flows in this branch, it means that Ix is equal to 0. Now from there, if we put value of Ix over here, that is in the dependent source, we will get this value also equal to 0. So the equivalent circuit will come out to be that the 5 ohm resistance will be in parallel to the terminals A and B along with the assumed voltage, that is 1 volt, and the current I0. Now we can simply use the formula I0 is equal to V by R. That is, we have assumed the voltage to be 1 volts and resistance is 5. That is, I0 will come out to be 0.2 ampere. Now that we have to find Rn, we will use the formula V0 by I0 as we used in Thevenin theorem. So now from here we will get the value of V0 that we have assumed, it is 1 volt, and I0 we just found out, that is 0.2 ampere. Now from there we will get the value as 5 ohm. That is, Rn has now come out to be 5 ohm. Now we will draw an equivalent circuit in order to find In. In that case we will short circuit A and B, but we will leave the circuit as it is. That is, we won't make any changes in the circuit, and we will short circuit this part, that is ISC will flow from here. So now we will draw the ISC equivalent circuit. Now we have drawn the equivalent circuit for ISC. As you can see, we have short circuited the A and B terminals in order to find IN or ISC. Now from here, that is in the first loop, you can see that we have a 10 voltage voltmeter in this branch. So we know that voltage is equal in parallel resistors. That is, all in this branch also we will have 10 volt voltage across the 4 ohm resistor. So from here we can find the value of Ix by using the formula Ix is equal to V by R. Here we have V as 10 volts and the resistor as 4 ohm. So our Ix will come out to be 2.5 ampere. Now at node A, we will apply KCL. That will give us ISC, that is ISC is equal to 10 by 5 plus 2Ix. Now we will put the value of Ix that we found out from here and get the value of ISC to be 7 ampere. We have found out the value of ISC by applying KCL at node A, and Rn we found out in the previous step, that came out to be 5 ohm. Now we will draw the equivalent Thevenin circuit. That is, we will draw ISC over here, and in parallel to it we will draw the RN resistor with terminals A and B. So guys, this is our final answer, and this question is very important as it contained dependent sources, which make the question a little complex, as we have to assume 1 volt voltage source across AB when we have to find RN. Otherwise, the steps for ISC are similar to when we do not have any dependent source. I hope you have watched my Thevenin theorem video, because that will help you in understanding the Norton theorem perfectly.